Hey, what's up, folks? How is it going? This is Avik here, and welcome to Devops Lab. So let's start with today's interview question. And today we have a couple of questions on EKS security. And before we go to EKS security, we'll just quickly have a look at standard EKS deployment flow quickly, high-level flow. So this is the flow we'll look at where we are taking a Flask app, which will say Hello World. It's a web app. So first step is just create the app.py recommend of PHP, and you have this hello world from EKS. Okay. And then you containerize the app, you write the Docker file, etc. And once you write the Docker file, you do Docker build, Docker run, and test the app. Then push the app to Amazon ECL. So you create repo, get the login, tag it, and push it. Then you create the EKS cluster. So you have the cluster configuration and create the EKS cluster. After that, you add storage. If you need storage, you can add storage class, and PVC, YML, persistent volume claim you add. And once that is deployed, and then you deploy the Flask app. So you create a deployment, replicas tool, or you have environment file dimension, volume, mount, volumes, etc. So once you deploy the app, you create internal service. Okay. And you create the service. After that, you deploy it and then expose the app to internet. Then you expose this app to internet. You're creating this, and this is Elvin this internet facing. Flask service port number 80 we are exposing. And then this will give public access to my LV. And then you do secure access. So you map your IAM to role-based access control. So this kind is role, and you do the mapping, service account mapping. And then you apply that, and you control your app or user, you control what your app or user can access. And finally, harden security in deployment, and then test it out. Okay. So this is the whole process. So today we will look at the security related question. So first question is, how do you implement role-based access control in EKS? Role-based access control. So role-based access control is who can do what. Like for example, IAM user gives you authentication. So with IAM user, you are able to authenticate. You are able to get inside. You are able to connect to EKS cluster, etc. You are able to get inside that cluster. But with EKS, you can decide with role-based access control. This will give you a permission whether you can delete the pod or only view the pod, those kind of things. So it's a authorization. IAM is authentication, and role-based access control is authorization. So, for example, role-based stands for role-based access control using Kubernetes to control who can access what. Dev users can only view pods. Admin can create or delete resources. CI/CD pipeline may have some special access to certain namespace. So in Amazon case, IAM controls users' roles from AWS can authenticate into the cluster. Once you authenticate, role-based access control tells what user can do after login. After login, what user can do. So even if an IAM user is allowed to log into the cluster, role-based access control decides what they can actually do inside the Kubernetes. So IAM is for authentication, role-based access control for authorization. IAM, who can authenticate to the cluster, and role-based access control in Kubernetes, what user can do inside the Kubernetes. So let's say IAM user is kubetest user. And we will look at this example where we are granting kubetest user to read-only access to pod. So we have this setup, we have created this user, IAM user, kubetest user, and this is the ARN, Amazon resource name, kubetest user. And then this we have to make sure that this has a permission for in case cluster, disk type cluster, assume, STS, assume, etc. It has proper access permission, and after that we have to update AWS auth config map to allow IAM access. So this IAM user maps to Kubernetes. So we are here mapping the user. what we are doing, mapping the user. This cube test user, we are mapping. Mapping to what? We are mapping to read-only group. So this cube test user can authenticate and map to the read-only group. And finally, we create a role-based access role. Here we are creating role, and we are creating authorization read-only group, read-only group, read-only group. Kind is a group, read-only group, and it can only get list bot. So it's a read-only thing. And since this user is part of this read-only group, it will be able to do read-only operation. So that's it, like role-based access control we have created here. And now we can test it. We can just check. We can do a case update, test user, update the kube config. And then if we do kubectl get pods demo, it should work. But if we do kubectl delete pod my pod, it should fail because the role is read-only. Role is read-only. Right? So that is so there are two parts, like one is a IAM, other one is a role-based access control. So real world use case, your developer wants to view pods but not doing anything. DevOps engineer to manage deployment only in dev namespace. CI/CD system to scope permission, not full admin rights. So this kind of real world use cases are there for role-based access. Next one is what is AWS IAM integration with EKS? What kind of IAM integration we do with EKS? So first one is control who can access the cluster, like admin dev CI/CD, who can access the cluster, right? And second one is control what running pods can access in AWS. So pod, which is the container running, whether it can access S3, whether it can write into DynamoDB. So that also we need to do IAM integration. So these are the two different things. One is user, whether user is able to authenticate and get inside the cluster. Other one is app inside the pod, that container running, whether it can upload to S3 or write into DynamoDB. So two key parts of IAM integration in EKS. One is a cluster access user, which we do using AWS auth config map. We have to map IAM user with Kubernetes user that we have seen. And second one is pod access to AWS service. That is IAM roles for service account. IAM roles for service account, IAM roles for service accounts. It let the app in pod access H3 DynamoDB securely. So they are the two different integrations. So part one, that first one, we have seen that we have to do AWS auth config map, where we are going to map the user. We do the map user. IAM user can be mapped to some group, and that group will have some access, role-based access control. And the second one is IAM roles for service account. So secure way to attach IAM roles to Kubernetes service account. What we do, we create IAM role with AWS permission, then attach OIDC trust policy, then create a service account and link that to IAM role. In Kubernetes, create a service account and link that to IAM role. Again, kind of mapping. And pod uses that service account to get AWS access automatically. So here, we are doing allow IAM role trust policy, allow, and then we are getting service account here. YML file service account. Again, we have annotation. IAM role annotation, my app IRC, and this service account name is this one. Now pod can access AWS service account like S3 or DynamoDB with final permission. How do you configure service account in EKS? So service account, how do we configure? Let's say we have a pod in EKS that needs to access S3 bucket to upload logs or DynamoDB table for read write. So how does pod get AWS credentials securely? So as we discussed earlier, IAM roles for service account. So I have to attach IAM role to Kubernetes service account so that automatically it gets AWS credentials securely and scoped. So service account will be mapped to the IAM role, and IAM role will have whether it can do S3 upload or DynamoDB, and it will have scope permission. So this is the one, like IAM. We already covered this one, discussed already, like enable IAM or DC provider, create IAM policy, and then After creating the policy, create I am role with trust policy. And then SC access role you have created. Then attach the role policy. And finally, create a Kubernetes service account with annotation. And then use that service account into deployment and what is the deployment. And here you use the service account. Use this service account. So once you use the service account, this deployment will be able to upload to S3 or write into S3 download to database. So it's a I am with service account. We use OIDC, trust. Then so there are multiple steps actually. Create first is a OIDC provider, like enable I am OIDC provider. Then I am role with trust policy. Then create Kubernetes service account with annotation. Then user service in your border app deployment. Next question is what are the security standard and how do you implement them? So there are PSS rules. PSS rules are control how secure the pods are. Privilege, no restriction, good for debugging. Baseline, prevents known bad practices, safer for most workload, and restricted, very strict, follow best practices for least privilege. So privilege, where there is no restriction, baseline, it is good, moderate, restricted, a lot of restrictions with it. So why do we need PSS in EKS? Because pod could run as a root, more mount host paths, and privilege mode. So that will be risky. Like it can run as a root, it can mount the EC2, accessing EC2 machine itself, and privilege mode. Full admin access. So PSS lets you enforce rules at the namespace level to protect the cluster. So pod security standard set some rules to protect the cluster. Choose your namespace, add level to enforce the PSS. Pods in the dev namespace must follow restricted policy. Pods in the namespace must follow the restricted policy. So now let's go to the next one. How do you handle secret management in EKS? So the basic secret management like database, SSH, AWS credentials, we can there are three options. First option is Kubernetes secret. It's a basic. So base 64 encoded, storing etcd. So in YML file, you can create a secret, username, password, admin, and this is the password, base 64 encoded. To serial apply a secret. So this secret will be stored in the etcd. And then in the pod, you can access it. In the pod, like let's say a DB user, secret reference, DP create, and username, you can access it. But it's not encrypted at rest unless etcd encryption is configured. So secrets are visible to anyone, access to the namespace. So second option, which is production friendly. So first one is you can keep it in the etcd and just create a secret, Kubernetes secret or YAML, and then just apply it. And then you can use that reference. Second one is you keep it in the secrets manager. Secrets manager will encrypt it with KMS, rotate the secret, and store your secret in secret manager. And then you create a Kubernetes service account. And using the service account, we can access that. Like using service account, app can access S3, you can write into database. Similarly, it can access the service secret manager, AWS secret manager, and it can get the. And another option is secret store CSI driver. Not going into detail, but this is another option like secret store CSI driver. So methods are Kubernetes secrets, AWS secrets manager plus IRS, service account and secrets manager, and secret store in CSI driver. So what are the security best practices for EKS? So first is access control. Like we already discussed, role-based access control and service-based account. Like who can access the cluster and what your app can do. Like what AWS service your app can access. Like whether it can access upload to S3 or write into a database or not. So role-based access and IRS, these are the two things. The network level security. Network policy is to control port-to-port traffic, whether who can talk to whom, right? For that, we use Calico or Cilium to define who can do that. Then isolate the environment using namespace to separate dev test code and security group. So that is network level. Then we have secrets management, normal secrets to Kubernetes secrets, OML, or you can use AWS secrets manager. Then node level security, manage node groups. We have to apply AWS patches properly, and we have to use AKS optimized Amazon Linux, fewer package, smaller attack surface. If there are fewer packages installed, smaller attack surface. It should be regularly updated. Yeah, then we need to apply that port security standard PSS label namespace with enforced is equal to restricted, so that it should not run as a root or limit privilege description. Do a hardened port configuration. So these are some important things. Then image security, image use Docker image should be like security scan should be done. TV we can use to scan it. So these are the important points: access control, role-based access, or service level service account. Then network security, policies, namespace, security group, secrets, secret manager, nodes, right? No auto patching, pods, enforce PSS, no routes, read-only FS, auditing, enable cloud trail, VPC flow logs, audit logs. Auditing is also important. And then image security, scan images, etc. So these are the things we can do. How to start? First, you set up the role-based access. Then you set up service account. So that app that use AWS service, what they can access, what AWS service they can access. Then you set up Kubernetes. It creates initially there, you can store your private password, etc. Then later you can move to AWS Security Manager. After that, you can have EKS managed node group. Then enable namespace with restricted port security. Enable audit logging in EKS settings, and scan your content images with 3D. So let's go to the quiz section. What is the purpose of using role-based access control in EKS? Encryption to control users or roles can access Kubernetes resources. To control which users or roles can access Kubernetes resources. The answer is C. Why should we use IAM roles for service account? IAM roles for service account in EKS. You can pause and try to answer. To let pods securely access AWS services without hardcoding credential. Answer is B. Otherwise, we have to hardcode the credential in the pod and then it's accessing S3 bucket or writing into database. So if we don't do that, role-based access, that's why we enable service account. IAM roles for service account. Where are Kubernetes secrets stored in default AKS? It's default stored in etcd, Kubernetes data stored. What is the main limitation of Kubernetes secrets by default? They are stored as a plain text unless etcd encryption is enabled. They are stored as a plain text. That is the problem of limitation of the Kubernetes secret. So that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel. And also follow my LinkedIn page, Devops Challenger. I post quiz contest daily, organized quiz contest daily. You can participate in that. Also follow my WhatsApp channel, Devops Challenger. There I post the updates regularly. Thank you for watching this video. See you again in the next.